So hi students, welcome to NSEJS physics classes. So the topic that we are going to discuss today is about gravitation. So previous classes we have discussed motion and force and laws of motion. So the next topic that we are going to discuss here today is about gravitation. So it's a very basic concept that we are actually learning. Gravitation is something which we can experience or which we can see around us very frequently or and it is very known to us. Gravitation is something which is actually relatable to us in our daily life, and we are also experiencing gravitation in our day-to-day life in different situations, right? We are able to stand here on earth, we are able to stand here, or we are able to walk here on earth because of the gravitational pull by the earth. Likewise, whenever we throw an object, it is coming back to us only because of gravitation. Otherwise, if there wasn't any force which is acting upon that body that we are throwing up, then it will be going outside the earth for infinity. So it is a force which is actually helping us stay inside the earth or helping us remain inside the earth. So gravitation is a very basic fundamental force. Okay, so today with our point of view, with our exam point of view, or with our syllabus, we will be mainly focusing on the different topics of gravitation. One is gravitation, then if you look at the topics that we are going to discuss today, is gravitation is a small chapter, but it has a large amount of concept that we have to cover. So if you look at the topics that we are going to discuss today, we'll be mainly discussing about gravitation. Then we will be discussing the major law, like universal law of gravitation, which is the law governing all bodies having masses, and it is the governing law for gravitation. So Newton's law of gravitation also it is known as. So we will be discussing about universal law of gravitation. Then we will be discussing on force of gravitation of Earth. Like initially, like I said, we are able to stand here, we are able to survive here on Earth because of the gravitation. So it's like a delicate balance. If the amount of gravity is exceeded within a certain limit, there will be a difference in the way that we are actually living inside the Earth. Okay. So force of gravitation on Earth is an important topic. So these are the three topics that we will be discussing today, and mainly we'll be focusing on the like previous classes. The style of teaching was like we will be discussing on the concept, and then we will be discussing problems after once the concept is finished. So today, once again, welcome to the topic gravitation. So as I said, gravitation will delve deeper into gravitation and the concept that are related to gravitation. Okay. So if you look at gravitation, like we know that gravitation is something which we can experience in our day-to-day life, right? So if I throw something upwards, it is coming backwards, coming back to the point, or it is falling back down only because of gravitation. So there is this anecdote, or there is this very interesting story related to Sir Isaac Newton and an apple. So there are two famous apples in the world. One is obviously Steve Jobs' apple, and the other one is Isaac Newton's apple. So the story goes on like this, like Newton was at his home, so there he was actually sleeping down under beneath or under an apple tree, and he actually saw one apple being falling down to earth. So that actually gave him the idea, like that actually planted a thought in his mind. Like he thought that why is the apple falling down instead of going up? So till then there was no such thought arised from different scientists or different scientific minds around the world. So back then it was actually Earth. People used to believe that Earth was the center and everything orbited around the Earth, including the Sun and the other planets. But then Galileo came in, and then he actually observed. He From his observation, it was clear that Earth is not actually the center. Instead, Sun is the center, and other planets along with Earth are rotating around the Sun. But he wasn't able to provide a specific reason on why the planets are being orbiting around the earth, or orbiting around the sun, or planets are being orbiting in a definite orbit. So he wasn't able to give that particular reason. So it is then afterwards, like Newton had this particular thought after seeing that apple. He thought that why the apple is falling down instead of going up. So there should be something which is actually pulling it down, which actually causes the apple to fell down, or apple to fall down instead of going upwards. Like so basically there should be a force acting on something which is actually trying to pull it down towards the earth's surface, right? So that there came the force known as gravitation, which we are experiencing or which we are hearing in our day-to-day life. So the force which is actually attracting the apple towards the earth, or vice versa, which means it's not just a force which earth is acting, which earth is applying onto the apple and pulling it down. It is also a force. It is the same force by which the apple is pulling the earth also. So it's an attractive force. It's a mutually attractive force which is happening between the apple and the earth. So that mutual force of attraction between the two objects is basically known as gravitation or gravitational force, as we say it. So we have four different fundamental forces in nature. Like we have already studied force and laws of motion. So there we have studied different types of forces. So there are four fundamental forces of nature, which is electrostatic force, then gravitational force is there, strong nuclear force and weak nuclear force. So out of all these fundamental forces, gravitational force is one among the fundamental forces. But if you look at gravitational force, it's an attractive force. Like electrostatic force can be attractive and can be repulsive. Nuclear force is attractive, weak nuclear force is attractive. So gravitational force is also an attractive force. And the definition, as I said, gravitational force or gravity is the force of attraction between any two objects. So if I have an apple, like in the case of Isaac Newton, the apple and the earth, the both are actually exerting a force between each other, and that force of attraction is known as gravitational force. So gravitational force acts between two bodies having mass. So that particular concept is very important. Mass, there should be bodies having mass. So if you look at gravitational force, then we can think why the apple is coming to downwards or apple is coming towards the earth. But instead, if we say that the same force is applied by the apple to the earth, then why not apple is pulling earth upwards? The reason is that the difference in mass is actually creating that difference. Okay, so gravitational force is a very weak fundamental force, because in microscopic level, like if the involved masses are very small, then the effect of gravitational force is very small. And also gravitational force is something which actually depends on the distance between the two masses. So distance and the amount of mass is a very big factor in considering gravitational forces. So it's actually like out of all the fundamental forces in nature, gravitational force is the weakest of all fundamental forces. The reason being, it actually depends on mass. If the mass is large enough, then we can actually experience the gravity. We can experience the effect of gravity. And but at the same time, if the distance between the masses is also very large, then the effect of gravitational force is very limited. So gravitational force is a limited and a very small, like a very weak fundamental force in nature. Okay, so as you said, in the universe, gravitational force acts between every objects having different masses. So all the objects in the universe attract each other. So as I said, it's an attractive force, and every objects in the universe attract each other with a certain amount of force. But in most cases, the force is too weak to be observed due to very large distance of separation. That is the reason why we are not able to feel the effect of gravitation. Let us say, like in this particular statement, it is being said that every object in the universe attracts each other. But and the force of attraction is in a certain magnitude, but we are not able to experience it. The reason being, the distance between the two masses is very large. So if the distance of separation, as we say it, is very large, then the gravitational force that we can actually feel is very small. Actually, it's not that much significant. And if you look at gravity, what are the examples of like what does gravity do, or what are the things that gravity helps in? Gravity almost helps in everything in our day-to-day life, including standing, walking, jumping, everything. So it's a force which actually causes the planets in orbit around the sun. So the planets are orbiting around the sun in a definite elliptical orbit. That is because of the gravitational force. Like there is a force of attraction between sun and the planets. And imagine that if there wasn't a force of attraction between sun and the planets will fly away from the orbit. So that gravitational force is something which is actually keeping the planets in orbit. Then another, as I said, Isaac Newton's apple. So apple, it is actually the force which actually causes the apple to fall down, or anything. If I throw this particular pen or upwards, after some time it will be reaching a certain maximum height depending on how much fast or how much velocity I am imparting to this pen. And at a certain height it reaches, and after that it actually falls down because the gravity is actually pulling it down. Gravity is trying to pull it down and trying it to bring back to the earth. And something which is rolling downhill, that is also one example, which is actually because of gravity. Like if because of gravity only, that if something is in a slope or placed in a slope, so it actually tends to fall down because of gravity. So these are the examples where we can actually see gravity or gravitational forces. The influence of gravitational forces can be seen in these particular cases, not just these three particular cases, but everything. These are some examples that we can actually see gravity. Okay. Now, as I said, like this is a major law. Universal law of gravitation is a major law that we will be focusing on. As we said, now we have already discussed that gravity or gravitational force is the force of attraction between two objects having masses. So Newton was the first one who stated that it is an attractive force. So Newton actually find out a method on how to calculate the magnitude of force. So the universal law of gravitation states that how much the value of force, right? It actually states about the value of force and what are the factors that depends on the force of gravity or the gravitational force. So there are two factors on which the force of gravity depends. One is mass of the body, mass of the two different bodies, and the other factor is, as we already said, distance of separation. So distance of separation means it is actually the distance between two masses. Say let us say, for example, I am considering two masses m1 and another mass m2. And imagine, like when we calculate the distance, we know you usually take the center, like center of gravity or center of the masses. And let us say the centers are within a distance d apart. Okay, so the center of the masses are separated at a distance of d apart, which is known as the distance of separation. So according to Newton's law of gravitation, he states that the gravitational force, if we can call the gravitational force as F, the gravitational force depends on two factors. One is the mass of the two bodies, not just one body, because here two bodies are coming into interaction. So it depends on two bodies interaction. So it depends on the masses of two bodies. So it states that the gravitational force is directly proportional to the product of the masses m1 into m2. And also, initially we have said that the gravitational force will be very small when the distance of separation is very large. So it means when the distance of separation between the two bodies is large enough, then the effect of gravitation will be small. So the reason behind that is, so we can say that the gravitational force is inversely proportional, because as distance of separation, like distance between two masses increases, gravitational force is being reduced, which means distance of separation is inversely proportional to the gravitational force, but not directly inverse, like it is inversely proportional to the square of the distance. So it is also known as inverse square law. So the gravitational force depends on two factors. One is the mass of the two objects that are in action or that comes into play. And the other thing is the distance of separation. So gravitational force is directly proportional to the product of masses. So if the masses are large enough, the product of masses will be again large enough. So then it will actually depend directly on the gravitational force, which means if two bodies are there having certain good quality or good quantity of mass, like large masses, then the gravitational force of attraction between them will be large. But at the same time, distance of separation is the second factor that gravitational force depends on. So if the gravitational force is inversely proportional to the square of the distance of separation or distance between the two masses. Okay, so which means if the distance is actually increased, say for example, if the distance is doubled, then the gravitational force will be reduced by 1/4 because of the inverse square law. Okay, so these are the two factors in which gravitation or universal Newton's law of gravitation, gravitational force depends on. So first one is, as I said, it depends on the masses, which is known as law of masses. So if you look at the law of masses, it says that gravitational force between object increase with increase in the mass of object. So that is why, like initially we have said that it is a very weak fundamental force in nature. And if the forces, like we are not able to feel the gravitational forces because of the negligible mass, because there is no subsequent amount of mass for the gravitational force to be felt. So it depends on the mass. So if if there is increase in the mass of the objects, then there is increase in the gravitational force. Whereas inverse square law states that gravitational force between objects increases as the distance between the object decreases. Or in other words, vice versa, gravitational force decreases when the object distance between the object increases. Okay, so this is inverse square law. So in the first, we have two cases. First one, there are two objects. So smaller object and larger object is there. So according to law of masses, in the first case, like imagine that it is having same distance. Like imagine the two bodies, smaller and larger objects are placed at same distance. So in the first case, the gravitational force, let it be F1, whereas in the second case, the gravitational force be F2. So if the distance is constant, if the distance remains the same, we can say that F2 will be greater than F1. Why? Because F2 has more combined mass. So the product of masses in F2 will be larger. So the gravitational force will be larger in the second case. Provided here we have stated a condition, the distance should be constant. Okay, like imagine if object 1 and object 2 are placed at a distance d apart, then the distance should be constant. So if the distance is constant, then we can say that the force, gravitational force only depends on the masses. Okay, so now if you look into the second case, inverse square law, we have same object having same masses. Object one, like, but the changing, the factor that we are changing here is the distance of separation. So in the first case, the distance of separation is more, whereas in the second case, the distance of separation is lesser. So here, if the masses are constant, and we know that it is inverse square law, which means if the distance of separation is larger, means the gravitational force will be how much? Gravitational force will be lesser. So in the first case, if we say it is F1 is the gravitational force, and in the second case, F2 is the gravitational force, here we can say that F2 gravitational force, F2 is larger because the masses are closer to each other. So the distance of separation between the two objects decreases, then the gravitational force will be increased. So that is what inverse square law states, which means the gravitational force increases when distance is reduced. Means the two masses have to come closer together. If the two masses come closer together, then the gravitational force of attraction between the two will be increased. Okay, so that is universal law of gravitation. So now we have two general equations, like two proportionality equation. F is directly proportional to m1, product of the two masses, and F is inversely proportional to 1 by square of the distance. So if we combine these two, we can say that F is directly proportional to product of masses m1, m2 by d square. So we will be multiplying it with a constant in order to change the proportionality sign. So the constant that we will be using here is termed as capital G, m1, m2 by d square. So we have a new equation known as F equal to G m1 m2 by d square. So this equation is actually known as the gravitational equation. So Newton's law of gravitation actually helps. So from this equation, we can actually calculate, if we know the masses of two objects, say m1 and m2, if we know the values of masses m1 and m2, and if we know how much the masses are being separated by a distance d, then we can actually calculate the magnitude of gravitational force by using the equation G m1 m2 by d square. So G is known as universal gravitational constant. So G is a constant, and the value, like the value, every constant will be having a definite value. So the value of G, which is known as the universal gravitational constant. So value of G is actually experimentally determined by the scientist Henry Cavendish. So we can also state that from this equation, we know that G is equal to F into d square by m1 m2. Okay, so which means that if imagine that we have two masses m1 and m2, and unit masses, two unit masses, which means 1 kilogram each. If we have two masses 1 kilogram each, placed at a distance of separation of 1 meter, unit distance of separation. So if it is placed at a distance of 1 meter, then there will be certain amount of force acting between the two. So universal gravitational constant is this will be G equal to F in this particular case when we substitute the values. Distance of separation is 1 meter and masses is 1 kilogram and 1 kilo. So we will get that G is equal to F, which means universal gravitational constant is also equivalent to the force of gravitation, force of attraction between two masses having mass 1 kilogram each with the distance of separation 1 meter. Okay, so that is, so if you have certain mass, if you have mass, two different masses of 1 kilogram each, and if you place the 1 kilogram as a mass at a distance of 1 meter, then there will be a certain amount of force of attraction, gravitational force of attraction. So that force of attraction will be equal to the universal gravitational constant, which is experimentally determined by Henry Cavendish, and the value of G, or the value of this particular force, will be equal to 6.67 into 10 raised to minus 11. And the unit of G is very important. So if you look at this particular equation, from this we can actually derive the unit, right? So force has a unit of Newton, and distance, the SI unit of distance is meter, but it is distance square. So it is Newton meter square divided by kilogram into kilogram, which gives us kilogram square. So the unit of the universal gravitational constant, capital G, is 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. So this value is very much important in terms of doing problems and numericals, because normally you will be not provided the value. You have to learn that value. You have to by heart this value, 6.67 into 10 raised to minus 11 Newton per meter square per kilogram square, which is the universal gravitational constant. So that value will not be given in numericals in general. So this value is very much important. So as I said, universal gravitational constant, the capital G is a constant known as universal gravitational constant. So it can also be explained, like it can also be stated as the force of attraction, for gravitational force of attraction between two objects having mass 1 kilogram each, separated at a distance of 1 meter. Okay, so now if you look into the scenario where apple fell down to the earth, so we can actually state that we can actually calculate the forces by using the universal law of gravitation. So here, if m1 is the mass of the apple and m2 is the mass of the earth, and it is separated by a distance r. Normally, in terms of earth, we actually calculate the distance from the center of the earth. Okay, so imagine if it is separated at a distance r, then we can calculate the value like f1, let us say f1 is the force of attraction by the apple to the earth, and whereas f2 is the force of attraction by which earth is attracting the apple. So here it is clearly mentioned that both the forces will be equal, like f1 and f2. f1 is the force of attraction by apple to the earth, which means apple is actually pulling earth towards the apple, whereas f2 is the force of attraction by which earth is pulling the apple. So both the forces will be equal because both will be depending on the product of masses m1 m2 and inversely proportional to the square of distance between them. So sometimes you can this r and d, there should not be any confusion between r and d. Like it is nothing but distance of separation. So sometimes if you are using distance of separation as d, it is also fine. Sometimes it will be used as r only. So it's not a definite like mass, it's a general notation, like we can use r or we can use d as well. Okay, so there shouldn't be any confusion arising from that. Okay, from the difference in particular terms r and d. Okay, so universal law of gravitation, once again, if I say, it is actually universal law of gravitation consists of two different law. One is the mass, one involving mass of the two objects, and the other one is inverse square law. So it is also known as inverse square law because whenever the distance of separation is increased, distance of separation and the gravitational force is inversely proportional to each other, and gravitational force is inversely proportional to the square of the distance. So that is why it is termed as inverse square law. Okay, so from this, so this is one part where we can actually expect a lot of numericals, because we will be asked to calculate the force of attraction between two objects, stating their masses, and the distance of separation will be given to you. But as I said, you should remember the constant value, universal gravitational constant G, which is equal to, once again, if I write it, it is equal to 6.67 into 10 raised to minus 11. And the unit of gravitational constant is also very important. Newton meter square per kilogram square. Okay, so this is the value of universal gravitational constant. Now we have now we have learned the very important law governing universal law of gravitation is actually the governing law for gravitation. So now we will be learning about the gravitational force acting on the earth to the other objects. Like we are staying, like right now I'm sitting here on earth, or right now you are listening to my classes sitting down or standing. So that is because gravity is there. Like you are not flying away, because earth is actually applying an attractive force towards us, so that we are actually able to stay here or stand here. Okay, so the gravitational force of attraction of earth is something that we are going to discuss. Like if I say this is the case where there is a certain quantity, or there is a certain concept known as acceleration due to gravity comes into picture. Okay, so if I say that, imagine this pen being dropped down. So whenever I drop, like whenever I let it go, what happens is obviously, the gravity will be pulling the pen downwards, and the pen will be falling downwards to the earth, right? So that is because gravity is acting. And it depends on what are the factors on which the gravitational force between this pen depends on. It depends on the mass of this pen and the mass of the earth, and also the distance of separation between earth and the pen. Okay, so as I said, the pen is also exerting a force to the earth. The pen is actually trying to pull the earth towards the pen, but we are not able to see it significantly. Why? Because the mass of earth is very larger, like it's very much higher compared to the mass of the pen. So that is why, like you can also in effect, you can say that if this is earth and if this is the pen, like earth is falling down and sorry, pen is falling down and earth is stationary. Or you can think in another way that pen is stationary and earth is coming up. Both are actually equivalent. Okay, so gravity of earth. So when I drop this pen, as I said, gravity is there, it falls down. But imagine that I have a pen and I have a like another piece of paper or something, and if I drop it down simultaneously, which one will fall, or which one will reach their surface first? So imagine there is a pen and I have a piece of paper dropping down simultaneously. So which maybe which one, like pen or paper, which one will fall first towards the surface? So obviously the answer will be pen, because the piece of paper will be affected by the air resistance. So it will be falling, like it will be not falling vertically down, but instead it will be like falling zigzag and all the ways because of the air resistance. Imagine that like I actually created a vacuum. Like I actually sucked out all the air, and I actually created a compartment which there is no air. Okay. So then again I did the same experiment of dropping the pen and the paper at the same time. Then you can observe that experimentally, you can observe that both the pen and the paper will reach the surface simultaneously or equally. Like both will be taking equal amount of time, which means every object which is actually falling towards the earth is falling at the same rate, which means earth is pulling down. The gravitational force of attraction will be different depending on the mass of this paper and pen. But whenever something is falling down, the only force acting there, like whenever something is falling down, the only force acting there is nothing but gravitational force. Okay, like it is because of the presence of gravitational force that something is falling down. So whenever something is falling down, it is actually speeding up. The object is not in a constant velocity. The velocity is keeping on changing. Like if you, we can actually see that, like if I drop something from a large height, uh, when it reaches down, the velocity is keeping on increasing, which means the body is under acceleration. So the value of acceleration remains the same for every object, irrespective of their masses. So that particular concept is known as free fall, which means something is falling under the influence of gravity only. And as I said, every object will be accelerated, means every object, the velocity is keeping on increasing, and the value of acceleration is same irrespective of their masses. So that acceleration under the influence of gravity is known as acceleration due to gravity, denoted by small letter g. We have already used capital letter G, which is the universal gravitational constant. So this acceleration, because of the gravity, only under the influence of gravity, is known as small letter g, denoted by and it is known as acceleration due to gravity. So acceleration due to gravity is something which actually determines how much, or which actually determines how much the object is being pulled towards the surface of a heavenly body, like, or a planetary body. Like every planetary body has certain amount of accelerations, like gravitational force, because of the difference in their masses. So this acceleration due to gravity is a term which is actually depending only on the planetary body, not on the mass of the particular object that we are actually dropping. Okay, so this acceleration due to gravity gives us an idea about how much rate at which objects are being pulled towards the earth. Okay, so if we are actually focusing on the gravity of the earth. So whenever something is being pulled by the earth because of the force of gravitation, it is being pulled downwards towards the earth by a certain amount of acceleration, or it is being pulled at a certain level of speed. So that depends on the acceleration due to gravity, and it also depends on the mass of the planetary body. Okay, so that if you state what is what is gravity of earth, the gravity of earth is denoted by g. So the value of acceleration is a quantity by which we can actually determine the rate at which something is being pulled towards the earth. Okay, so if instead of earth, if I stand on the moon and if I drop the same pen, the moon actually exert gravity. Moon also exert gravity because it also has mass. The pen has mass, so there will be gravitational force. So the moon is also exerting gravity to the pen, but the rate at which the pen is falling depends on the mass of the moon. So we know that the mass of the moon is very lesser compared to the mass of the earth. So the rate at which the pen is pulled down towards the surface of moon differs. It will be different, and we can say that we can clearly state that it will be less than the rate at which the pen is being pulled towards the earth. Okay, so this acceleration due to gravity, denoted by g, is the net acceleration that is imparted to objects due to the combined effect of gravitation and centrifugal force. So we can actually calculate or we can derive how we will be calculating the acceleration due to gravity in an object on the surface of earth. So imagine that if uh, like excuse my drawing. Okay, so imagine that we have this is earth, and let us say that the radius of earth is denoted by re, and mass of earth is denoted by capital letter me. And imagine if something like if there is an object of mass m, small letter m, placed at the surface of earth, so the distance from the center to the object will be equal to the radius of earth, which is re, right? So this distance is the distance of separation. Like I have mentioned that we always when we are calculating or when we are measuring the distance of separation, we will be dealing about the distance from the center, like from the center of the two masses. Okay, so imagine if the distance of separation is equal to the radius of earth, then we know that there will be a gravitational force of attraction F, which is equal to capital G into mass of earth into mass of the body divided by the distance of separation, which is equal to the radius of earth square. Okay, now we also know that there is, because like weight and mass are two different quantities. So mass means it is actually the amount of matter, but whereas we have learned in the last classes and all, in Newton's law we have learned that force is nothing but mass times acceleration. So if an object is falling, imagine that if I'm dropping this pen, it is falling or it is accelerating downwards at a rate certain. So if only gravity is in picture, then we already stated that the rate or the acceleration at which an object is falling because of gravity is nothing but g. Okay, it is denoted by g only. Okay, so if only gravity is there, it is denoted by g. Okay, so that object, let us say, consider this pen for example. So if this object is being dropped towards the earth, this pen is being accelerated, so it can actually create a force, it can impart a force towards the earth on hitting, which is equal to mass times acceleration. So here the acceleration is equal to mass times g, because the acceleration is under the influence of gravity on. So if we can say that these are two forces. Okay, so we will be equating these two forces. So it will be m into g will be equal to the force of attraction of gravity, g mass of earth into mass of the object by radius of earth square. Okay, so from this we know that the mass of the object gets cancelled. So we are getting the value of g is nothing but capital G, which is a constant, universal gravitational constant, times mass of earth upon the radius of earth squared. So from this, it is clearly known that the acceleration due to gravity, the acceleration or the rate at which an object is falling towards the earth does not depends on the mass of the object. So it only depends on two factors, which is the mass of the planetary body and the radius of the planetary body and the universal gravitational constant. So since all these values are constant, we actually know the mass of earth is a constant value, radius of earth is a constant value, and even g, universal gravitational constant, is also constant value. So from this we can actually substitute those values, and we will be getting the acceleration due to gravity of earth as 9.8 meter per second square. Okay, so acceleration due to gravity, which means the acceleration or the rate at which something is falling under the influence of gravity, will be equal to 9.8 meter per second square. So this is very important in terms of doing numericals also. Like sometimes what happens is during numericals, we are like time management as a, like the in introduction, I already mentioned that time management is something which we should be very much focused on competitive exams or objective type of exams. Okay, so there we will be using a lot of mathematical tricks, like we will be approximating a lot of steps. So whenever we are dealing with calculation which involves acceleration due to gravity, during calculations, sometimes, not every time, sometimes or most of the time, we can actually approximate the value as 10 meter per second square, because it is almost equal, like the accurate value is 9.8 meter per second square, but during calculation, for the simplicity, we will be approximating it as 10 meter per second square. Sometimes it will be directly mentioned in the question that you can take acceleration due to gravity g as 10 meter per second square only. Okay, so gravity of earth is actually, gravity of earth or even gravity of other planetary bodies can be measured in terms of the rate at which something is falling towards the planetary surface, which is known as acceleration due to gravity. Okay, so it is a combined effect of gravitation and the centrifugal force of the planetary body. And one main thing we have to remember is acceleration due to gravity does not depends on the mass of the objects or mass of the individual object. So that is why, coming back to the previous example where I used a pen and a piece of paper in a vacuum. Like vacuum means there should be no air resistance. Air resistance should be negligible, or there is no air, so air resistance is zero. So in a vacuum, when two objects are falling, only force which is influencing the fall is gravity. So two objects are falling, which means it will be under free fall, and it will be falling under the same rate or same acceleration, which is known as acceleration due to gravity, and both will be having a value of acceleration as 9.8 meter per second square, which means we can also state that like 9.8 meter per second square means if I am dropping an object, like every second it will be having an increase in speed of 19.8 meter per second. So if I'm dropping something at the first second, after 1 second, the speed of the object will be 9.8 meter per second. Then after 2 seconds, the speed of the object will be 19.6 meter per second. So each second, for every second, the speed, the velocity is increasing by a factor of 9.8. So that is what acceleration is, right? Acceleration means nothing but the change in velocity per time, which means velocity, how much the velocity is being changed with respect to time, or in each second how much velocity is being increased by a factor of some number. So here the velocity of the object whenever it is falling down is increased by a factor of 9.8, which is known as the acceleration due to gravity. Okay, so acceleration due to gravity, once again, if I recollect what I have said, is it is denoted by small letter g, and it only depends on three constants, three values actually, which is, one is universal gravitational constant, the other factor is the mass of the earth. Like now we are actually talking about the gravity of earth, then radius of the earth squared. Okay, so these are the factors on which acceleration due to gravity is depending on, and it will be equal to 9.8 meter per second square. Okay, so now we will be solving some one example question where we can actually expect in NSEJS. Like normally what happens is we'll be the questions that is based on the acceleration due to gravity will not be asked directly to find out the force or something. We'll be asked to compare, or we will be asked to find out the ratio, or what will be the change in acceleration due to gravity in two different planets and all. Okay, so we will be solving one example and then we will be winding up the particular session. So the rest will be taught in the next classes as well. And the next classes will be mainly focusing on problem solving only. So here there is an example question. So what is the change in acceleration due to gravity? And the mass of a planetary body is doubled and radius is halved. So here we are not talking about Earth. Imagine that we have a planetary body having a mass capital M and radius R. So in this particular, so initially there will be an acceleration due to gravity denoted by, let it be G. Okay. So this acceleration due to gravity is for the initial condition of planet, which is having a mass M and the radius R. So afterwards, what happens is, imagine we have done something so that we have actually changed the mass of the planet and also the radius. So here it is stated that when the mass of the planetary body is doubled, which means mass is doubled, the mass has become 2m and the radius is halved. So radius have now become r by 2, which means the mass have doubled, mass have increased and the radius have decreased. So what will be the new acceleration due to gravity g dash? New acceleration due to gravity g dash will be equal to, so we already know that acceleration due to gravity depends on universal gravitational constant, mass of the planetary body, and the radius of planetary body. So this is the initial condition G. Now we know that if I am calculating G dash, which is the changed acceleration due to gravity, so that will be equal to universal gravitational constant remains the same. It is G only. Now the mass has been changed to 2 times m, 2m, divided by the radius has been half, or radius is decreased by 2 times. So r by 2. So here we can actually write it as G dash is equal to 2 gm by, sorry, r by 2 the whole square. Okay. So r square by 4. So this will be equal to 4 goes to the numerator. So this will be equal to 2gm into 4 by r square. So I'm writing it here only. Okay, so G dash is nothing but P order 2 into 4 will be 8 G M by R square. Okay, so 8 GM by R square, which is, this is nothing but G. We already know that GM by R square is equal to the initial acceleration due to gravity. So G dash is equal to 8 times G. So these kind of questions, or now we will be asked, or also we can take the ratio, like ratio of the new acceleration due to gravity G dash to the initial acceleration due to gravity will be equal to 8 by 1. So these are the type of questions that we can actually expect in gravitational chapter. So these are the topics that we will be discussing. Now we will be winding up the classes. So in the next classes, we will be solving more and more problems related to the particular topic of gravitation. So see you in the next class. Okay, so next class we will be further discussing on free fall, and then we will be solving a lot of numericals also, numericals related to NSEJS. Thank you.